My name is Rob Lalonde, and I'm going to kind of host things today. Welcome to Migrating HPC Workloads to the Cloud. We're excited to get going. I know a number of people are still joining. We had almost 200 registrants, which we're thrilled with. And as you might see, we are recording this event, just so you know. We've got a couple of great presenters here from Intel and AWS. We'll start at the bottom of the HPC stack with Intel. Brock Taylor is here. We've worked with him for a number of years. He's director of HPC solutions at Intel Corporation, and he's working to drive broader adoption of high-performance computing across industry and academia. Isaiah Weiner is here with us. He's the senior manager for solution architecture and strategy for 14 different technology areas at AWS, including, and I like to say most importantly, HPC. So welcome, Brock and Isaiah. My name is Rob Lalonde. I'm Vice President and General Manager of Cloud here at Univ, and I'm responsible for the go-to-market efforts around our cloud migration solutions. So we're each going to do a brief presentation from our different perspectives on the marketplace, Brock, Isaiah, and I, and then we're going to have what I hope is a really fun panel discussion. So settle in wherever you are. Webinars in the age of COVID-19 can be more interesting than previously. We'll have FedEx at the door, and we'll have dogs and children participating. So we will see what happens. So Brock, over to you.
Yeah, thanks, Rob. And I almost jumped the gun on you on the slides. So, yeah, I'm Brock, and I'll give just a quick glance of some of the high-performance computing work that we do at Intel. We're kind of into everything, so a lot of different things, and part of it as well. We have lawyers, so I do need to just flash up our notices and disclaimers that essentially are saying we'll have some things, names aren't necessarily our own if they're not Intel owned, and we have a lot of trademarks and brands. But ultimately, Rob, I may need your help here. I have lost control to advance my slide.
Let me repass you control.
Apologies, everybody. And as well,
it says you have it.
There is a 25% chance that my dog will participate in the webinar today. So hopefully he won't, but just in case. So yeah, now we've got it.
Working now?
It's working too good. So Intel, I can just talk to the previous slide. Intel really takes a holistic approach to HPC. Again, we're not just hardware. We actually are a significant software presence as well, and Intel is one of the largest software companies in the industry. Actually, we have about 20,000 developers company-wide that work on all sorts of different things. But in relation to high-performance computing, we have a range of silicon, starting with our Xeon processors, but extending into some of our networking chips, our persistent memory products, and our storage products that really provide a rich feature environment for HPC and artificial intelligence. Couple that with our world-class software development tools in Intel Parallel Studio that include compilers and analyzers, cluster tools like Intel MPI and Cluster Checker, all the way down to some community software that we help enable that really helps maximize value of Intel architecture and take advantage of a lot of the performance features that we have in our silicon products. And with that, we have a code modernization process, which is where Intel works with the community and works with application developers specifically to dynamically link our runtime libraries, our performance libraries, so that when we make innovations in our silicon and introduce new features in silicon, existing applications are going to take some advantage without having to change the code, and then work with them to decide when they update the code or modernize the code to take full advantage of the new features and gain even more performance. And then as we introduce new silicon, the process starts all over again. So it's that code modernization that helps advance applications continue to see performances year over year, performance gains year over year from various parts of the innovations that we're putting into our products. Let's see. I am suddenly getting a lag. Rob, if you're able to advance for me, just go that way. So one thing that we started about 15 years ago is looking at HPC clusters and talking with a lot of the application vendors on some of the problems that they faced, where every HPC cluster looked different to them, very unique. And we started working with integrator partners. We started working with OEMs, and we started working with the system software ecosystem to help define a common interface and a definition that applications could rely on and march to, and help increase the interoperability of the HPC applications, or traditional MPI style applications, with clusters without having to know as much about an individual deployment. And so we created a platform specification for Intel-based systems that really targets when you're building on Intel. We were able to find some common memory and shared storage and local storage amounts that applications needed just as a base. We looked at the different Linux distributions and found a base level kernel that everybody could agree on, and analyzed applications for common library and utility requirements, and wrapped that into the specification so that you get this common Linux base. And then on top of that, we looked at, here are the software components, again, things coming out of Intel Parallel Studio. We have runtimes so that when the applications that are dynamically linking, they can rely on the Intel runtimes being there that expose those best performance paths. We put that into a specification, and we actually wrapped around that some programs to help validate it, to help show that a system provides that interface to the applications, and basically give a way that both solutions vendors and application vendors could pair up without having to know as much about each other. And we saw some really good success. We started that formal effort in the industry in 2007, and we've curated the specification over the years, modified it, and made it a little more modular, and something that allowed us to really expand on it in terms of HPC solutions. So Rob, let's go to the next slide. And that evolution allowed us to move to this composability of solutions. So again, we started with traditional HPC applications that are more the simulation and modeling HPC space. It's where a lot of our commercial application codes live. It's where a lot of the community codes live as well. And we've also added an advanced Intel visualization option. So you have this base solution that provides broad applicability to HPC applications. You can layer in a visualization capability to do visualization work in situ on your Xeon cluster, and then tie into a lot of the popular frameworks out there like ParaView or Visit. Tie that into the applications that you're running so that you get the visuals as well, right? But then we're able to layer more vertical solutions on top of that simulation and modeling solution. And the first two that we've done is a genomic stack, where Intel has a long-standing engagement with the Broad Institute, taking their tools, making some modifications within the genomics toolkits to take advantage of Intel optimizations, layer that on top of the solution, and actually produce something that is a really targeted life sciences cluster capable of running things like GROMACS or cryo-EM workloads, as well as genomics, all in the same system, right? So compose a solution that does both.
Everybody wants to know what the pig is with the Starship Enterprise on its back.
That's not our icon. That is the icon for Cromwell, which is one of the Broad scripting frameworks to launch genomics workloads. Yeah. It is funny. We've debated on what they mean by that, but that is not our icon. That is a Broad icon. As well, we've done HPC AI convergence, and this is part of a collaboration we've done with Univ as well. But we're adding in a lot of the popular machine learning frameworks on top of a traditional HPC system, and using a multi-domain resource management technique to be able to schedule both traditional HPC MPI style jobs as well as machine learning jobs on the same system, right? So converge down to one HPC infrastructure that is capable of running both. So that specification has allowed us to get to this level and continue to march through and just add to the amount of applications that interoperate with these systems and really increase that interoperability and out of box and speed to use of the system for what you intended. All right, Rob, let's go on. So then we've been looking at cloud for a long time. It has been a while, but definitely the past few years, things have absolutely heated up. And we know that 2019 has been labeled as the tipping point for HPC in the cloud. One of the things that we've been able to demonstrate is replicating this approach into the cloud. So, from an application point of view, the cluster that's on-prem and the cluster in the cloud look very similar, or can look very similar. And so by replicating this environment, we've been able to actually show that you can migrate a lot of these applications very quickly and very easily and get the same type of environment, right? As well, it does not preclude or exclude more cloud native approaches. So we've actually demonstrated you can containerize applications and drop them into these environments as well. But it's really a way to make sure that we've got the right mix. Not all applications are cloud native. Many of them are trying to get there, but we've got this way to take the existing applications, get them running in cloud, help meet that pin-up demand that we're seeing, and allow people the flexibility to run where they need to. Okay, Rob. So I'll turn it over to Isaiah here in a minute. If you want some more information, I did include some links for a lot of our HPC effort. Again, this is a part of it. Parallel Studio, distribution of Python, which has a lot of our connections to our performance libraries as well. You can go investigate those offline. So Isaiah, I'm going to turn it over to you now.
Hey, cool. Thanks. Appreciate that, Brock. Hey, everybody. I'm Isaiah. I'm a Senior Manager of Solutions Architecture in the partner team at AWS, and I have the great pleasure of working with partners like Intel and Univ. Amazon has actually quite a long history of working with Intel, and if you sort of go back and look at a lot of the instance types that we've deployed, several of them have been processors that have been collaborations with Intel that you actually couldn't you couldn't even sort of buy off the shelf or buy through other vendors. If you wouldn't mind, Rob, could you just advance the slide for me? I've been clicking to get control, but it hasn't been working. Thanks. So this is a sort of a high-level view of what are the knobs that you have in front of you as an AWS customer, and what are the typical components that you might see in an HPC deployment. For folks who are coming to the cloud and they're used to HPC, there are things that they traditionally haven't really been responsible for, things like security or IT functions related to networking, and those become really pertinent when you start talking about hybrid deployments, making sure you don't have things like overlapping IP spaces and that you're using the right authentication mechanisms and directory services systems. But what people do know is they do know, how to get their job scheduler deployed, how to define their jobs, and how to manage frequently the software that they're using for their solvers. So step one is usually, how do I get the data into the cloud, unless I'm using maybe a public data set or I'm generating intermediate data off of a relatively small data set. And for that, we have our Snow family. In fact, there was a new release this week of something called Snow Cone, which is a lovely little sort of tissue box sized device that has a couple of virtual processors on it, a bit of memory, and a healthy amount of storage in the same sort of form factor as the big briefcase sized I say briefcase, I guess I mean luggage-sized snowball device that's a ruggedized computer that is great for offloading data from your on-prem environment and bringing it into the cloud. But a lot of that has sort of traditionally been targeted at data sets that don't change. And so what we frequently find is that customers who are going to be deploying in the cloud, what they actually want is they want a way to sort of move things over the network in a reliable way. And so we have a series of services around that, not the least of which is Direct Connect, which is, you can think about it as sort of a private line management system to plug into your virtual private cloud in AWS, as well as other services like Data Sync, of which actually Univ has integrated with to help you sort of move your data sets into the cloud so that you can get started. And getting started frequently means turning up instances, identifying shared storage for those instances to use, and looking at how you can get the software deployed that you need to in a way that's going to be able to let you do the most in the cloud with the least amount of work. Frequently, that also means some form of remote visualization. So the last thing anybody wants to do is go generate a bunch of data and then have to pull it back down to view it. So we have great solutions for that too. Some through acquisition, some through just existing technologies that happen to run really well in the cloud. Next slide, please. So why do people go to the cloud for HPC? There's sort of three reasons. The first one is capacity. We often say, there's nothing wrong with your on-prem supercomputer. It's just that there's a line to use it. And it's possible that you could be using something that maybe is at the tail end of your refresh cycle, and you might actually get better results in a much shorter period of time, even if there isn't a line, by using something that's newer. Refresh cycles for on-premises equipment can often be lengthy, up to even 5 years or more. Next slide, please. And so as a byproduct of that, we tried to put things in the most places possible. When I started at Amazon about 5 years ago, I think we had maybe 8 or 9 regions, and we find out about them internally at the same rate that people find out about them publicly. So I'm often surprised to go back and look at this map and see, oh, there's 5 more. So we do this based on customer demand. So in some cases, it's, for example, in EMEA, there's a lot of requests related to data sovereignty, GDPR-related regulations, saying, gosh, I'd really like to make sure that I can, do my HPC work and keep it inside of the places where it's supposed to be. In other cases, it's simply related to capacity. The larger Amazon gets, the larger our blast radius gets when we have problems. So we try to actively work against that. So that means regional independence for services as much as possible, even availability zone-based independence inside of a region, so that invariably when we will have a problem, as our CTO Werner likes to say, everything fails all the time. It will impact the fewest people possible. Next slide, please. Inside of those instances that I referred to that you would be running your compute job in, we've taken lessons that we've learned over, gosh, at this point, over 10 years, around how to do energy efficient, high performance, and things that lend themselves to good tenant boundaries. So strong tenancy boundaries are important in shared tenant environments like the cloud. How to solve for problems like not being your own noisy neighbor, often referred to as a peak to averages problem. These are things that we've worked super hard to solve for, and it's one of the reasons that people come to the cloud, because it's really hard to be your own noisy neighbor when you're using a service like Amazon S3. But if you were to try to go implement, like, let's say, a Ceph cluster on-prem, you'd probably be your own noisy neighbor pretty fast. And so that's one of the benefits to coming to the cloud. All of those lessons learned are implemented in what we call a closed loop feedback mechanism, so that we take those learnings and we push them into the next thing that we do. And so for our instance types, next slide, please. That means that we've developed some custom equipment to ensure that you're getting the most bang for your buck. And so traditionally, virtualization technologies have been done in software. So we've pushed as much as we possibly can into what people would probably describe as the hardware world. Next slide, please. And so the way we've done that is through the creation of something we call the Nitro card. And so we acquired a few years ago a company called Annapurna Labs, and at the time they were making mostly what people refer to as Ethernet accelerators. Now they make all kinds of things that are used inside of Amazon Web Services. But the first one that is relevant to HPC is our Elastic Network Adapter, and a feature of that Elastic Network Adapter is something called the Elastic Fabric Adapter, or EFA. And so by building this, we were able to preserve those tenancy boundaries and give you the maximum performance by offloading as much as possible out of the actual equipment that you're paying for and onto something that frankly would be overhead otherwise. So how do we get the best possible latency with the best possible bandwidth in a very, very large scale deployment? It's through the Nitro card. So we have dedicated Nitro cards in our instances for storage and for network, and there's management, security, and monitoring functionality built in. That EFA, Elastic Fabric Adapter, it's not InfiniBand, it's not OPA. Those technologies, unfortunately, don't work at the scale that we deploy things. So what we decided to do was, come up with, and happy to talk with anybody about this offline or later in the panel. What we had to do is we had to come up with a way that customers could deploy HPC workloads and get the same sorts of low latency, high bandwidth characteristics in technology that would be not too difficult for folks to integrate with. And so when we launched EFA, one of the great things about having Intel as a partner is that those adaptations that needed to be made to Intel MPI in order to support EFA were done pretty quickly, and that enabled a huge swath of solvers who were already supporting Intel MPI to adopt EFA almost immediately. And of course, there's other MPI libraries as well that support it. But what I've observed is that customers tend to standardize on a library and then stick with it for quite a long time. And so having customers already depend on Intel MPI and having Intel as a partner really helped there. Next slide, please. And so one of the things that people come to the cloud for as well is the ability to change their HPC workload. So if you, next slide please, if you bought something on-prem and you didn't know what you were going to be using it for, and you had sort of, think about it as like a generalized approach, and then your requirements changed later, you would be in a difficult spot, because it's difficult to say, well, gosh, I really need to go change this now. You have to start over in the procurement process, and maybe some of the stuff that you've acquired is reusable, and maybe some of it isn't. In the cloud, because you're paying for what you use, there's nothing to stop you from simply tearing everything down that you've deployed and then starting over. And so there's three ways to do that from a pricing model perspective. And the mechanisms that we give you are automation tools that are primitives, our APIs, as well as things like CloudFormation templates. But you're, of course, free to use third-party tools as well. For general cloud deployments, things like HashiCorp Terraform are super popular. When it comes to HPC, though, frequently you need to understand how your deployments link to what the job that you're doing is. And so that's where tools like Univ and NAVAP Launch come into play. And I think we'll talk a little bit more about that later. Next slide, please. Our instances are many and varied. This is a little bit of a sort of the anatomy of a label. So P3DN happens to be a GPU-oriented instance type of its maximum size. 24XL is the biggest for this type. There are other numbers associated with other types, all sort of based on a system of normalization called an elastic compute unit that I'm not sure if it's relevant anymore, but it's certainly where the number comes from. The D has to do with the fact that it has local NVMe storage, and the N has to do with the fact that it has 100 gigabit performance. Next slide, please. And so here's a good example of sort of how the smaller numbers, the 24XL turns into 16XL, turns into an 8, turns into a 2. And so with other instance types, for example, the C5N, those numbers get a little bit more granular. There's no GPU in the C5N, and that gives us the ability to chop things up in a more granular way. But you can see that it's not just the compute and memory, it's also networking and dedicated storage performance that gives you a bit of a scaling factor as well. Next slide, please. So those three pricing models that I mentioned, on demand, reserved, and spot, when people look at the prices, everybody wants to use spot because it's the cheapest. So on demand is, I would say, about 50% more expensive than what you would pay on-prem. Reserved is about on par with what you would pay on-prem, and spot is about 90% less than what you would pay for on-demand. And one of the wonderful things about spot is that it is super, super inexpensive to deploy things. One of the less wonderful things about Spot is that because it's based on surplus capacity, you can actually have interruptions, and so that means, unfortunately, that you need to sort of know how to handle those things. Next slide, please. Learning how to handle those things is something that you get through experience, but it's also something that you can learn from our documentation, and of course, it's also something that you can get from our partners. The ability to take advantage of that price point has often it's often sort of pivotal based on whether or not your workload has support for something that people often refer to as checkpoint restart capability. But as we've learned from our customers and as we've learned sort of from the service, interruptions are not constant. They tend to be seasonal in the sense that you can go for weeks at a time and not have any interruptions, and then you may get 4 or 5 interruptions in a day, such as the surplus market is sort of tend to behave. The HPC world, by and large, being very cost conscious, almost always is trying to shift its workloads to Spot. So if you think that the cloud is right for you and you believe that the right price point for you is Spot, then I think the next question that I would ask is just make sure that you've got the solvers that you're working with are able to handle interruptions. And sometimes that means you have to add a little bit of glue in the form of recovery scripts or special options to restart from those checkpoints. And once you get those things sort of taken care of, it's usually not too difficult to get started. I think that's it. That's all I got for you today, and I'll pass that over to Rob, and then we can talk more about that stuff later on in the panel. Rob's muted.
I am muted, and I was saying really important things. I was just saying, yeah, we're seeing some great questions coming in, so I'm excited to get to those in the panel discussion. But thanks, Brock and Isaiah. Univ is not as well known as Intel and Amazon, obviously, so just a quick introduction to us. We're up the stack, obviously, from the cloud infrastructure that Isaiah was talking about. We're in the workload management, scheduling, and cloud migration business. People would know us for our Univ Grid Engine product. We've been around for many years in HPC, and now our focus is more and more shifting to cloud migration. We have 250 customers. Real strength in life sciences. In fact, 6 of the top 10 largest life sciences companies in the world run Grid Engine. They're using applications like genomics and molecular modeling and machine learning, and lots of interesting ML stuff happening these days with cryo-EM. Incidentally, life sciences is really booming in the cloud as well, so we're keeping busy helping these customers go to the cloud. It's probably our number one vertical as far as cloud activity. We also have very large customers and a large base in oil and gas. These some of the largest enterprise oil and gas clusters in the world, in fact, are in our base. These customers are running seismic exploration workloads and reservoir simulation, as you'd expect. And then we have a large number of customers in manufacturing as well, both traditional manufacturers, the discrete manufacturers that you'd think of like Rolls-Royce and BMW and the F1 racing teams. And then we have the other segment of manufacturing, which is the EDA chip design space. So we've got the large auto manufacturers, like I mentioned, that can crash a car entirely in software and never scratch the paint on that car. And then we see a lot of CFD going on in that market segment as well. And of course, that's happening a lot with our F1 racing customers. On the EDA side, our customers are running a variety of regression and testing tools. They want to deliver better quality, obviously, time to market for the next generation chipset. So that's just a little bit about our base. As I mentioned earlier, a lot of people know us for our Grid Engine product, which is enterprise modern descendant of Sun Grid Engine. But more and more our customers are migrating to the cloud, and we've released NAVAP Launch 2.0 just earlier this year to help our customers get to the cloud. This cloud, it really isn't new for us. We spun up the first life sciences cluster in Amazon back in 2008. We've been building tool sets since then to help our customers go to the cloud, and NAVAP Launch is kind of the culmination of these tool sets in a complete suite of cloud migration capabilities. So we'll talk a little bit more about that in a little bit. What we're seeing with our customers is a real uptick in cloud activity. 2 years ago, we surveyed them. 50% of our customers were in the process of planning or migrating. Last year we surveyed them again. It was up to 92% of those customers are planning, migrated, or already migrated to the cloud. So that's a huge jump in the last 2 years. And I'll talk in a few slides about the drivers and why people want to go to the cloud at such a dramatic rate. But yeah, you can just see that that's a pretty significant shift in cloud activity within HPC. On the bottom left, you can see the types of deployments that customers are doing. So 34% wanted dedicated, 20% wanted hybrid, and 40% wanted both. I think that just speaks to the unique needs of the customers. And I think it's really interesting that a lot of customers want both. They want to burst their on-premise cluster, leverage that capital investment they've already got, but still get the benefits of this virtually unlimited capacity that Isaiah was talking about earlier, but also be able to spin up dedicated clusters when they have a special project, maybe something closer to the data, maybe something across the country, closer to where the end users reside or what have you. So we see a real mixed need, and that's why you see a real variation in the numbers between the three different types of deployment methods. In the middle, you see the spend association data. So 84% of the people surveyed are very interested in cloud spend management as a solution, but only 76% have deployed them so far. So I think that's a really interesting opportunity and speaks to why we've spent a lot of time with NAVAP Launch on tackling that spend management, because customers get to the cloud, they go, wow, that bill surprises me. We need to manage this more efficiently. Our end users, you always hear the horror story about the end user leaving instances running or leaving data lying around, and you get that surprise bill. So spend management is one of those things that you need to get to quite quickly after you start your cloud migration journey. And on the bottom right, you see that 54% of people scheduling work in the cloud are either using Slurm or Grid Engine, and that speaks to why we added Slurm support to Grid Engine just this year as well. So that was a big change for our company, being the Grid Engine people, and certainly a lot of activity around Slurm with NAVAP Launch as well today. As I mentioned, the drivers, and Isaiah mentioned them earlier as well, about the virtually unlimited capacity, and that's why they're seeing customers go to cloud. That's very consistent with what we're seeing. In fact, these two slides are consistent between Isaiah and I, just really worded very differently. Our customers have these great on-premise supercomputers or distributed computers, but there's a limit, right? There's only so much they can do on a given day based on their fixed capacity. So they've already got sunk costs on that. They don't necessarily want to dump that, but they do want to get results faster. So every single customer I talked about why they're going to the cloud, it really comes down to that. They want to get results faster. They want to do more. They want to make their product more competitive at a faster rate. They want to develop their drugs quicker. They want to do more research. They want to test their cars faster, whatever it happens to be. So this gives them the ability to meet the demand of the end users right when they have that demand, as opposed to queuing them up in queues as they go forward. Other drivers on the left-hand side, still important. Things like access to specialized resources. We hear that all the time from customers. We want to get access to GPUs. We don't want to have that capital expenditure on premise. We want the latest and greatest GPUs, so we'll just get them in the cloud. Or maybe it's big memory machines or some other specialized machines. It's amazing the variation of instances that Amazon has to meet an exact compute need. So that's a driver. Cloud-based data sets is another driver. We see it certainly in life sciences a lot, where NIH might have an adverse reaction database in the cloud that people want to access, or the customer themselves may have a cloud-based data set of genomics. Bringing the compute closer to the data can be more cost-effective in many cases than to move that data around out of the cloud, et cetera. So the proximity to data makes a difference for customers. We are seeing top-down pressure from executives. A cloud-first approach is the word that's used very much or very often, and that's a driver. And then we also hear data centers are just too darn expensive. These companies are in the manufacturing business for making automobiles. They're not in the business of building big buildings with heating and cooling and racks and servers. So if they can offload that complexity to another organization, essentially outsource that all the way up to, a very high level of the infrastructure tiers, then they're staying focused on their core competencies. And lastly, all organizations really like to have access to that updated hardware refresh. As far as the journey to the cloud, our customers are all at various stages. Some are just starting out and they're in the planning stages. Some are running small cloud-only clusters and just a single application. And then there's others that are right over on the right-hand side that are very advanced cloud presence. It's all integrated hybrid cloud management. They've got fully automated, all singing, all dancing cloud presence, and they deserve some congratulations for getting there. But it is a journey, and there's a lot of complexity. There's lots of learnings. The cloud isn't the exact same as the way things were done on premise, so you need to spend some time understanding and building up your expertise in that area. So we recommend start out left if you're new. Get experience with the authentication, the VPNs, the AMIs, all the nuances of your cloud environment. And don't go for the big bang and introduce a lot of risk to your project, but evolve along that line, migrating application by application, user group by user group, adding more capabilities. And I think you'll have a lot more success. And that tends to be the way that we approach things with our customers. The main capabilities that our customers seem to need, provisioning, certainly a big one, the ability to create and destroy cloud infrastructure, but it's really an underpinning of cloud migration, and it's kind of table stakes. It's expected to be there. It's not very exciting. There's lots of ways to provision and create cloud infrastructure. But in HPC, it's not enough. It's really that automation that is the straw that stirs the drink and makes organizations' efforts successful. Things like being able to scale up and scale down exactly when you need to. And these HPC clusters are very dynamic in many cases, right? There's workloads coming in, and all of a sudden you need 3,000 servers, and 20 minutes later you need 14. So your scale up, scale down rules have to be very sophisticated, very responsive as well. Instance selection, as I mentioned, you have all these different instance types at your disposal. You don't want to just run a homogeneous cluster in the cloud. It doesn't make sense. You want to pick the specific instances that match your workload, and this automation can do that. It can say, oh, here comes Jane's workload, and Jane needs a GPU. I'm going to go get one in the cloud for her, or someone else might need a spot instance for their specific workload, and that'll work fine because they've done the work that Isaiah mentioned with things like checkpointing and recovery, so they can use spot instances, so they'll get spot instances. So all these elements of automation make it really powerful to have your HPC cluster kind of growing and shrinking and meeting the user's demands without the HPC administrator running around and pulling levers and doing all kinds of different work to match the things that the users are doing at that point in time. The triggering data movement's another one. You'd want to have done by the automation so that the data arrives in the cloud prior to provisioning the instances. There's no point in having instances waiting around for data. With these three capabilities working together, we really think that you get much more efficiency. So if you see something happening with your spend management, an application not running efficiently, you could tweak your automations to get a different instance. Maybe you're memory bound, and then you will provision that instance and run the workload again and continue with the cycle of optimization as you go forward. So this is NAVAP Launch. On the right-hand side, you can see the NAVAP Launch dashboard. You can see what's been spent at the highest level, and you can drill into that by various departments. You can even look at it at the workload level to see what spending's done. You can see how that department is performing against budget, or overall as a company you're performing against your budgeted cloud spend. You can even turn off an organization if they've hit their monthly quota, and they may not like that all that much, but it's in the art of the possible. You can look at what infrastructure has been deployed here in the middle, and you can drill down to that to see what's actually happening on your cluster or your various clusters. And you can dig into efficiencies on the right-hand side. And this is really important because this really closes the loop on those automations I talked about earlier. So if you see that a specific workload is not running efficiently, let's say it's memory bound, you may want to go look at a different type of instance for that. Change the automation so that workload XYZ now gets a big memory machine going forward, and you're going to rerun that workload. And you can see how some AI and some automation down the road would apply to this and allow you to automatically change your automations to be much more efficient as you go forward and to test various scenarios. So our customers in the cloud are using NAVAP Launch in, really various ways. As I mentioned earlier, we've got hybrid clusters, we've got dedicated clusters, we've got people doing both. We're doing a large life sciences organization right now, a big deployment where they have dozens of clusters, all of the infrastructures as code. It's a real slick deployment. We've done the Million Core project in EDA with Amazon about a year and a half ago now. That was a pretty exciting project. We went over 1 million cores on that cluster for multi-physics testing, and they found a 60 times reduction in the time to get results versus their on-premise clusters. So scale is not a problem, and that's a big driver for a lot of our customers. Maybe our customers don't want to get to 1 million cores, but we're certainly hearing lots of them saying 20, 30,000 cores at different points in their business cycles is important. Wharton at UPenn, they're a business school, obviously. They're bursting to Amazon when they need additional capacity. They have a pretty small cluster on-premise. A number of years ago, they threw out their aging GPUs and decided we're just going to get fresh, brand new GPUs in the cloud when we need them. The end user doesn't have to change any of their efforts. They simply submit their work. NAVAP Launch says, oh, you need GPUs? Let me go get you some. Provisions them, attaches them to the Grid Engine cluster, and the work just runs, and those end users are none the wiser that their work ran in the cloud versus on-premise. And I think that's really important. And it's one of our overarching goals is to make it easy for the end users to do the work and have no change in their work experience. We also want to make sure that we reduce administrators' efforts, reduce the time they're pulling levers, and we really want to make the organization meet their compute requirements goals as well. So those are kind of the three overarching goals for us with NAVAP Launch. So what I'd like to do now is turn it over to the panel and have a little bit of discussion. We have a few questions we thought would be interesting to kick things off. So I'll do that, and then we'll get to some of the questions from the audience. So let's start out with Brock, and Isaiah, I'd like you to follow up on this one as well after Brock, but tell me about Intel and AWS's collaborations and highlights around HPC right now, because I know you guys have been working together a lot and you've been breaking new ground on all kinds of new initiatives.
Yeah, and I see we've got a question or two on EFA. That's one of the big areas that we've collaborated on. So I alluded to some of the work that Intel does with communities. We have a couple of people that focus on working with the libfabrics group and actually driving a lot of improvements in just the interface to advanced fabrics that HPC needs. And we couple that with Intel MPI work. And Intel MPI was actually launched to provide a multi-fabric approach to applications. So you didn't have to recompile for a specific fabric. You just switch it at the MPI level at runtime. And so that allows us to work with fabric providers for the fabric vendors for providers that plug into the libfabrics layer and work with Intel MPI. And then a lot of the optimizations we're able to do is go in and tune Intel MPI specifically for fabric and work with, in this case, we worked with Amazon on the EFA drivers and the providers to make sure that we've exposed optimal path to help bring down those latencies and realize advanced fabric for HPC.
Great. Isaiah, do you have anything to add?
I think absolutely. So that is probably the most impactful thing to HPC workloads in the cloud. For a long time, there was just sort of a checkbox requirement that was missing around, do you have InfiniBand, do you have OPA? And the answer was no, because they won't work in our environment. So, our networks don't look like normal networks, and that's because in our environment we have security, as Andy likes to say, Andy Jassy, our CEO, security is job zero, and so we've had to sort of architect things a little differently. Second reason is due to economies of scale, just being able to manage things, support concepts like failure in place and basically lower our costs over time. We've had to do a lot of things ourselves that, maybe, in years prior, we would simply, pay somebody to deliver a product for us but that isn't how you drive your costs down when you're using things at scale. And so working closely with Intel on not only the instances, but also on this, pivotal technology has been really advantageous. And if Intel wasn't, such a not just hardware company, but also software company as well, that would have been so much harder.
Yeah.
Absolutely. Great. So another question is, we're seeing a lot of HPC and AI convergence, and we're dealing with it every day. Our customers are dealing with it every day. So it's just happening almost without us even realizing it, how much AI is going on the HPC clusters. But what trends and directions are you two seeing?
I can.
Go ahead, Brock.
I was going to say I can start and then I can turn over to Isaiah. So we at Intel, again, part of our effort is we have a team that's dedicated to working with the maintainers of the frameworks and framework developers. We're providing optimized libraries to take advantage of Intel architecture underneath. Again, so the users of the frameworks don't have to figure those things out. And again, part of our platform approach is to make sure that you've got the right tooling there so that performance is realized. So our distribution of Python includes a lot of those performance libraries or links from the Python libraries to the performance libraries underneath, like DNN and DAL, so that those things are transparent to users. And as well, if you don't have those, it's also transparent. And what you see is just the performance isn't as good. So one of the trends, I think, as we see more people trying to employ AI in workflows with traditional HPC. On-prem, we have the converged single infrastructure, and then in the cloud, you have that option, but as well, you have the options to spin it out to different instances. And so I think a lot of the trends are how you knit those workflows together. And that's where I think our partnership with you guys, Rob, with Univ, helps people do that. That's your specialty, is helping them land these workloads in the right places and realize the gains from both their local and on-prem.
The machine learning taxonomy is extensive. I can't begin to describe how crazy it is. There's a lot of niche out there in machine learning, even more than in HPC, I would say, and I think that's saying something. So there's hundreds of solvers out there that to sort of do the same thing in different ways to accomplish slightly different results. Machine learning is no exception. What I see customers using machine learning for is to narrow the search space. They still have to go do their simulations, their brute force simulations, but by setting up the right sets of boundaries and constraints, either by informing those boundaries and constraints through machine learning or by using machine learning as like a first pass methodology, it can reduce the amount of work that they have to do later, and therefore the amount of time that it takes.
Yeah. Exploration of design parameters is something I think we see a lot of, but I would say we're at the beginning and we don't know where it's going to go, which is kind of exciting.
Totally, absolutely.
So Brock, I think you had the next question.
I'm curious, Rob, you kind of alluded to it. You get a range of partners, but when people come to you and say, I've heard the cloud, I want to use the cloud, what do you tell them? How do you tell them to get started?
Yeah, I think that goes back to the slide I had with the kind of the 4 clouds on it, where there's lots of complexity in the cloud. If you're pure on-premise customer, you're probably not familiar with Amazon's DNS solution and AMIs, and you don't have a VPN set up. So I always recommend, let's start small. Let's start with a POC, a single application, not a big data set, so that you're not incurring a bunch of costs there. Keep it to a simple application, not a complex workflow, and get started and find out what you don't know and learn along the way. And then you can start determining and expanding your environment and building out your automations and seeing what what instances run best in your application, because you don't know at that point. You can't go for the big bang and just start running everything. You won't be efficient. So you got to learn how these different instances perform for your applications and tune that and do a lot of testing and playing. And then when you start to have this expertise, you can start to just roll out application by application and user group by user group, and eventually get to this all singing, all dancing, fully automated cloud cluster. But it is a progression that's going to take, a number of months to 18 months kind of thing to get there. And Isaiah probably has some thoughts on that too.
Oh yeah, 100%. So people, the cloud is not. I mean, it's all about how you use it, right? So like it can just sort of be a place where you run workloads. You won't get the most out of it if you just think about it as a like a big colo facility. But there's a lot of work that HPC people have sort of traditionally just never had to do. HPC people that we hire are staggeringly bad at things like when they first get there, at things like security or IT stuff, right? Because they're the end user, right? They're focused on how do I solve the business problem? How do I solve the end customer problem? Somebody else has always done that. And so, we go through this process with our new hires where they got to get certified because we ask our partners to do it. And, we're not going to ask our partners to do something we're not willing to do. I mean, I've had folks say, this is the hardest test I've ever taken in my life. So, and it has everything to do with the fact that they just haven't been studying it for the last 20 years. So, this is the sort of thing where bridging that gap between what somebody doesn't know about IT and where they need to be in order to make things sort of come off without a hitch. There's a lot of lessons that you can learn from other customers, and that's where partners come in. So having that experience, I used to work with a guy who said experience is what you get when you don't get what you want. And I love that quote because I feel like Univ has got a lot of experience, in helping customers get to the cloud because they've been doing it for so long. They've been doing it for over 10 years. So one of the things that people talk about is sort of like the stops and starts associated with trying to, they go read a blog post and they say, it's so easy, just do this one cool trick and like away you go, and it isn't like that, most of the time. Sometimes it is. It depends on what you're trying to do. But like, if you're only using, the stable versions of open source tools and, from soup to nuts, like maybe it'll be that way because somebody wrote a script to check that stuff out and it's been tested recently. But most of the time, the HPC environments on-prem have grown organically and changed organically, and adopting those organic changes to a totally new environment sometimes takes a little bit of tweaking. And so, it ends up being one of those things where a lot of customers they start with tools that Amazon produces and maintains, like Parallel Cluster, great tools, but they don't allow you to run workloads in multiple regions. They don't let you manage even multiple availability zones. They're sort of very, very simplistic deployments. And so people get started and they're like, okay, now I want to scale. Now what do I do? And so they need a different set of tools that were designed with that in mind. They need tools that were designed with hybrid deployments in mind, with multi-AZ deployments in mind, with the notion that they actually, if they want to take advantage of a spot market, the spot market fluctuates region to region. So, and in sort of a follow the sun type fashion on price.
Right.
Price and availability, and so you need tools that are aware of those things, and so you end up in this it's not the mountain, it's the rock in your shoe thing when you try to go do it yourself sometimes. And so what we're looking for is transformative customer experiences. We want the end customer to be able to utilize the cloud with minimal friction, and that's what why we come to Univa and say, hey, you guys, let's invest in this transformative customer experience, and you have, and customers speak very highly of you.
Yeah, I like to say we're not removing the complexity of HPC. We're abstracting it as best we can.
For sure.
Yeah, they are highly clusters in the cloud, highly complex. Clusters in the cloud are more complex because you're adding everything that the on-prem system needs, plus the additional things. And security, like you say, most people haven't had to think about it because the compute resources, at least, have all been entirely disjoint from public view. So, interesting, great stuff.
Absolutely. So I'm going to go to a couple of questions from the panel. Sorry, Isaiah, did you have something to add?
Yeah, I was actually just going to say we should tackle that because there's a lot of good stuff in there.
Yeah.
Okay, yeah, let me do that. So the first one was I was on a little early and you guys were just talking and it sounds like there's going to be a data center on the moon. Can you comment on that?
Yes, I have no idea when. I'm sure there will be at some point. It'll run very cool.
Okay, let's kind of set you up on that one a little bit. So Sam's got a good question, and it actually meshes with one of the ones I was going to ask anyway. So he's saying, out of curiosity, what is the most common showstopper to migrating applications to the cloud? And then he specifically mentions licensing, technical limitations of the product solution.
Oh, I think it's both of those things.
Yeah.
The first one is definitely, there's often sort of, the question about, it's not necessarily getting the license server up, like that's actually not that hard. The problem is making sure that you're, sort of operating within the right terms. So just understanding what your license is and understanding how scaling your workload will impact that. Different solvers have different models. Some solvers are charging you based on concurrency. Some are charging you based on the size of the individual jobs. And the biggest, I would say, limitation once you get started, like how do you limit the scaling, is probably storage. Actually, almost all problems kind of come down to I/O problems, and there's good third-party solutions for that if you find the limits of our native stuff. But FSX for Lustre is our native solution that we recommend for HPC. If you have a workload that is pushing the limits there and you want something that's faster, the fastest file system on the planet right now is WCA-IO. And actually, Univ and WCA-IO have done work together in the past to support each other, so Univ customers can expect a good behavior there, from like a what to expect, that thing's going to just work. So really, and that was built in the cloud just for what it's worth, and it's one of the reasons why it works so well there. Understanding I think when people do go down the spot workload route, understanding that things like interruptions, and this relates to one of the questions, is sort of, are there any statistics around spot interruption rates? No, there aren't, and that is because it's dependent on your bid, effectively, right? How the pool. So we cannot, unfortunately, for SEC reasons, publish those statistics, but what we can do is we can help you develop a strategy for how to develop your spot fleet requests to backfill lost instances with different types of instances. We can help you develop strategies for how to run jobs in parallel regions or availability zones with multiple spot fleet requests, and we're always looking to improve that. So if you do have problems, please let us know. So give us a feedback mechanism.
Yeah, absolutely. I agree with you. I think that the data one is really challenging. Just making sure that, how are you going to manage your data? How are you going to manage the results getting back, your egress costs, cleaning up storage when we get to a lower cost tier afterwards? If you leave that to the end users, you're going to have a mess in your hands. There'll be data orphaned all over the place. So you really need a system and policies and ideally automation to drive the usage and management of that data.
Yeah,
most people don't have responsible storage policies, like just on-prem, like, you bought it, you fill it up, you go get more, right? And like in the cloud, you can't really fill it up, so you can. So it's important to be responsible with your policies there, for sure. There was a couple other good questions around sort of latency for EFA. What's it dependent on? The EFA mechanisms for latency are largely dependent on what else is going on as well. So I would say it's not always below 15 microseconds. In fact, it could, depending on what you're doing, it could easily be 30 or 40 microseconds. But we are always working to get it lower, and that's the benefit of it being a service and not a product. Things are always improving. Our goal is to get it down into the single-digit microseconds.
Sweet. Okay, we're getting close to the top of the hour here. I'm going to take one more, and then any others we will just try to answer offline via email. There's just some great questions in here. So Sam asks, in what regard does Univ accommodate Slurm? Does Univ provide a deployed infrastructure that has a Slurm schedule installed and configure? The answer is yes. So NAVAP Launch has a kitting mechanism where the workload manager, whether it's Grid Engine or Slurm, comes in a kit, and that kit is utilized by NAVAP Launch to create the clusters. So it's kind of like a meta RPM type of technology, the kit. So yeah, you have a Slurm build inside the product, and then you can leverage that and spin that into clusters as you go. So hopefully that answers your question, but I know Sam's got a couple others here, so we'll get to you via email, and if it doesn't answer your question, you can have some follow-ons. But given the time, I think we will wrap. I really appreciate Intel and Amazon joining us. They did a fantastic job. We appreciate all the attendees that joined us, and we will circle back with the recording to those who maybe didn't catch the whole thing and get it out to you. So look forward to future sessions with you all. Thank you very much for attending.
Thanks, Rob. Thanks,
yes,
Isaiah.
thank you.
It's great.
Yeah. There's somebody on the attendee list who has a birthday tomorrow. He knows who he is. Happy early birthday, Gert.